Welcome to Beyond the Forecast. I'm Chief Meteorologist Jeff Edmondson along with Kristy Steward, who's joining us. Welcome.
Thank you. I'm happy to be here.
Thank you. So this is your first time being on Beyond the Forecast. This is going to be your first time answering some of these viewer questions, but you've answered viewer questions before because you've been a meteorologist for a while now.
I have for like almost a decade now. I've been doing weather things.
Yes. Where did you start your career in weather?
Okay, so went to school at Penn State.
Oh, Penn State, okay.
Yeah, Penn Stater. So I consider that kind of the start because we did have a lot of broadcasting things. We had our own studio that we could use for weather. We had live broadcasts that we would do. We had student-run shows. So kind of like it was a good entry into TV. So did that from freshman year until I graduated senior year. Then I went to Bowling Green, Kentucky. I was the morning and noon meteorologist there for 3 years. Then I went to here, and I was at the competitor.
Yep, crossed town for a little while.
Yep, crossed town for a little while for 3 years. And then I took a break from TV. I went to public affairs for the Navy, for Navy Region Mid-Atlantic. And then now I'm back in TV with Wavy.
Yes, and it's nice to have you join us. This is going to be fun.
Yeah.
It's going to be fun to get to know each other. We've crossed paths before throughout our career. We first met at the Bayou Bon Vivant several years ago when it was 95 degrees, scorching hot like it is right now.
Yeah, I'm surprised that you remembered which event it was. We have so many events that happen around here.
That was the event where we had a live shot later on. I think you were doing something else at that time, but the beignets came out with Steve Fundero and one of our other reporters who's no longer here at Wavy, and I got coated in powdered sugar. And it was 90-some degrees outside, and I was caked in powdered sugar on the air.
Yeah.
So,
that's a memorable one.
It's a memorable one. Not a memorable one. So for viewers that haven't seen you, because they've been just watching us or they're new into town, just kind of tell them what kind of like you do. What do you like to do outside of work? What are your favorite kind of things to do when you're at work, weather-wise? What do you like?
Okay, lots of things. All right, so outside of work, I'm into bungee fitness. So a lot of people don't really know what that is. It's kind of a newer thing that's becoming more popular. We've got a couple of places around here. But you're in a harness, you've got bungees that are attached to the ceiling, and then you do workouts. Like we'll do burpees, we'll also do flies, and just things like that. It's a little bit of a easier but more fun workout. Like it's not as hard on the knees. So that's always nice.
That's good.
As doing like, a lot of squats on your own and stuff.
So this is where you're kind of like you strapped in, you're going, whoa, and you're working yourself up, but you're also swinging through the air, right?
Yeah.
Okay,
so,
I've never done that.
Yeah, no, it's pretty cool. We get
fun.
to do a lot of cool different things. Unique flies is what we call them. You do all kinds of things in the harness. So that's a lot of fun. I also have a dog and I've got 2 cats. So I like to hang out with them as much as possible at home. My dog, she likes the beach. So usually we go out to the beach, especially, well, we haven't been in a while. It's been too hot.
It's a little too hot. The sand on the paws
a little
and
too
on our
hot
feet.
recently.
It's a little too hot. I think it was like a week or two ago they said that the sand was around 139 degrees or something like that.
Yeah, crazy. Yeah, way too hot. So eventually, when it starts to cool off a little bit, maybe we get a couple cool days in there. We got to go to the beach. We haven't had a trip yet this summer.
Yeah, this time of year is typically the hottest time of the year for us.
Yeah, it is.
So,
and it's feeling like it.
It totally is. We had that heat wave in June. Feel like we're in another heat wave right now, even though we really aren't.
Right.
We're seeing temperatures around average, but it has been super, super hot. What's your favorite season?
I like summer.
Okay, so this is your time to shine.
I like warm weather. So when I I'm originally from Raleigh, North Carolina area. So I grew up kind of more in the South, went to Penn State for school, and I was like, yeah, no, I hate the cold, hate winter.
Okay.
Snow is pretty. I like to look at it, don't like to drive in it.
Okay.
And the cold, I remember I was walking to class one time my freshman year, and I got a brain freeze from the wind. And I was like, no, this is too cold here. So I had to move back south. So we get, a little bit of cold. It's not too bad. As
the viewers know, I love wintertime. That's my favorite season.
Okay.
And I do love Raleigh. I've been there a couple of times. Raleigh reminds me of Minneapolis of the South.
Yeah.
The rolling hills, how the city is kind of set up, more so in the suburbs. I don't know the downtown area very well. I've never been downtown. But the outside areas, kind of like Cary and other communities.
Yep.
It's a really nice spot. It's a really nice town.
Cool. Yeah, Cary is exactly where I was born and raised.
Oh, that's the spot. Yeah. So it
there
reminds me of Minneapolis in a way, how it's laid out, how the stores are, how things are kind of hidden behind trees.
Yeah.
It's not wide open, clear cut. It's a beautiful city.
Yeah, it is really pretty. It has grown so much. I remember when I was in college and I would go home for breaks, and there was always something different. I'm like, oh, that's not there anymore. Or, well, that's new.
Right.
And like, so it just around that time frame, it just really exploded.
The only difference is that there's not as many lakes around the Raleigh
Yeah.
area. There still are several, but there's
Yeah.
not as many as what we have in Minnesota, land of 10,000 lakes.
Yeah, I don't think you can beat that.
No,
You got that
can't
name
beat
for a reason in Minnesota.
No, we're proud of that. Yeah, winter's my favorite season, definitely. I love
Okay.
driving in the snow when the roads are unplowed, where you're just
Okay.
floating when you're driving and you don't even
Yeah.
hear anything. Just
Yeah.
it's crazy. I like
Well, you had
biking
a
in the
lot
snow
of
too.
snow in Minnesota.
Yeah, we get
Yeah.
on average around 54 inches of snow in Minneapolis.
Yeah, that's
every
crazy.
winter. Duluth, I used to work and live there.
Okay.
They get around 86 inches of snow on average in a winter.
Man. Yeah, so I have my extended family, like my grandparents, aunts, uncles. They live in Minnesota. They're in southeastern Minnesota near Rochester.
Okay.
So-
You're the Mayo Clinic.
Yep. So yeah, they share snow pictures, and I'm like, yeah, you guys can have that. I only visit them in the summer.
Yeah. That's
We
smart.
went there for like a family reunion in the middle of October, and it was already like 30 degrees and starting to see snowflakes.
Yeah.
And I was like, yeah, no, that's too much for me.
Yeah, yeah, it happens fast. There's been in northern Minnesota. It has snowed every month except I believe June,
Wow.
or was it July? One of the two. I can't remember the stat now because I don't live there anymore. But
Yeah, that's
every
crazy.
month. Every month.
Crazy.
All right. Well, we're not going to talk about Minnesota this episode. We're going to be talking. We're going to be hanging out more with Kristy, learning more about her. We're also going to be
Yep.
answering your questions because this has been the last time we did this. It was a huge success with the
Okay.
questions that we got. We got some really advanced ones
Awesome.
this time. So we're going to be taking some deep dives into stuff that some things I had to do a little bit of research on. Some things I still don't know all and everything about.
Okay.
So we're going to kind of work off of each other a little bit and see if we
Okay.
can figure out what the answer might be.
I feel like you're going to test how much I remember from college.
Did you have like a nickname at your previous job, like you were the professor?
Yeah.
So we're gonna test that
Professor
nickname.
Kristy. Jen Lewis, I know some of you know her because she used to work here too. Yeah, she used to call me Professor Kristy
Okay,
for our weather trivia that we did. So we'll see. We'll test it.
we'll start with the first one. This is from Becky. She recently came back from Denver visiting her son, and they have really bad hail in the spring. And I was told that larger hail causes the clouds to turn a greenish color. Why is that? Why are the clouds turning green? So when we get that process of precipitation inside a thunderstorm, inside a cloud, that can change how the light is going through the cloud. It obviously gets darker. We know that because we're absorbing more visible light. But the visible light, excuse me, can also be filtered out a little bit too, leaving behind that greenish color. And we tend to see that more with hail. Have you seen something like that before when you've gone maybe storm chasing?
Yeah, so it's really crazy to see that happen in the sky when it just turns this green color. But yeah, where was it? Probably Oklahoma, I would say. So I've been storm chasing across the U.S. 3 different times.
Okay, you've done some chasing.
Yeah, done some chasing. That was in college. We had a storm chase team, so we would go out in May for about 10 days, and we would just go across. Usually we would end up going out as far west as Colorado and come back. But yeah, so obviously kind of out there in Texas, they had some good storms out there. Oklahoma always had some good ones, but there were a couple of times that we saw that greenish color,
Yes.
and it's very crazy. But we would always avoid it because we're like, yeah, we don't want to go into that hail.
No, right. You don't want to go into there.
Yeah, exactly.
You definitely want to go into it. First time I think green skies became mostly wide known to the public is probably from the movie Twister.
Yeah.
I would say, I mean, people that live in Tornado Alley or that live in areas that see the hail, okay, they're probably more familiar with it before the movie.
Yep.
But in terms of widespread across the country, oh, greenage, you know,
Yeah.
going green.
Yeah.
That was the saying from, what was his name from the movie? Dusty. You've
Yeah,
seen
yeah,
Twister,
yeah.
right?
Yeah, it's been a while since
been a
I've
while.
seen Twister. I saw the newer one.
Dude,
I remember that one.
you like
more.
that one?
Yeah, I like that one.
It was good.
I thought it was good.
It was good.
Yeah.
I like the original because the music was great from Van Halen.
Okay,
That was
that's fair.
great from their band. That was good. But both movies, the second one definitely lives up to the hype that it needed to.
Yeah.
It keeps it going.
And they did their research, which was good because I heard that they went and they chatted with National Weather Service
They
and
did.
all of that stuff. And it shows, I think, it was
did.
pretty accurate for things.
Yeah, it was actually a lot more accurate than the first one. So
Yeah.
they did
That's
a good
cool.
job. That was fun. Yeah, so if you're seeing that greenish color, that's from the hail that's being formed inside the cloud. The hail forms inside the cloud because that freezing level is lower. So the point at which the temperature drops below 0 degrees Celsius or 32 degrees Fahrenheit. We're generating that hail inside the thunderstorm. The thunderstorm that has a stronger updraft, it can lift larger chunks of ice, larger hailstones, so we get larger chunks of hail inside the thunderstorm. A stronger thunderstorm will have typically a stronger updraft.
Yeah.
So that's how we're getting the hail. So huge hail the size of a grapefruit will be something that we won't get here in Hampton Roads. We'll get that in Texas. We'll get that Oklahoma, other states surrounding.
Yeah, that's good. We don't want that big of hail here.
Nope, we definitely don't.
They can have that.
That was a good question from Becky. That was good. One that we got last time we did this, and we ran out of time. This is from Robbie. This is when and it's more kind of a statement going into questions. And you've lived here in Hampton Roads for several years, so you get the tides. You understand them.
Yes.
Let's go through this from Robbie. When we have nor'easters or tropical events, I think people misinterpret the effect of a high tide cycle. And it's not just for a few moments. It builds up, and then it's a slow descent from the highest point that can last several hours. So, for example, we can have a high tide at noon, and it's 3 feet above normal. The effects for that noon high tide could start as early as 10 a.m. and last through 2 p.m. So for 4 hours, we're under the effects of that higher tide. So essentially, think of a tide as a bell curve in a way. It could be the low tide, could be the high tide. And there's times before when we've had tropical systems or nor'easters where there isn't a low tide. It doesn't happen.
Yeah. Yeah, so it is pretty crazy. So that was one of the things that shocked me, is because it's not only during these events. Like, I think that you could expect to have higher tide during nor'easters or tropical events, but what surprised me when I moved here, it can be sunny and you can just have those strong northeasterly winds, and then you get high tide and it floods the streets.
Yes.
Which is, I think that kind of also catches people off guard a lot. But yeah, you do have to think of it kind of, I like that, the bell curve. That makes a lot of sense to think about it. But yeah, when we talk about high tide is at 12, it's like 12, that's when it's going to be at its highest peak. So that's when that flooding is going to be the deepest across some of our streets and things like that. But it is going to be building gradually, rising, and then gradually falling as we head throughout the day. So you do notice that. And I guess, I don't know. I think people that are from here have kind of maybe realized that more. You see that happening more often here.
Right.
But I could see where visitors and stuff, you kind of have that, it high tide's at 12, so it's only going to be right at that time. But no,
Right
it builds.
It builds up to that point. It builds up to that point. So I'm pulling up a site here. Let me pull up the thing. So this is just from the National Weather Service. And apologies, it's a little bit small here, but this is their site for looking at the high tide gauges. You can choose the one that's closest to you. We'll show these on the air when there are conditions that warrant it, but you can see how the tide goes up and it goes back down. So for a couple of hours, when we have significant events where we see the level get up to these minor, moderate, or major levels, we can be above minor for hours. So we're getting those effects in the areas that see it first. We'll see the tidal flooding first. Where the areas that see it when the water gets a little bit higher, they'll, of course, see it closer to that high tide point in time.
Yeah.
But that's kind of how it works. It's a gradual increase. It changes most dramatically mid-tide, and then the changes are slowest at the extremes, at the high and the low.
Yeah. So very cool. I think that's a really good question, kind of be able to break down some of those tides. But yeah, it is very interesting out here, especially during some of those larger events. Like you said, we don't see that flooding necessarily clear off of the roads during a low tide, because we do have it still at that nuisance or action level, whatever you want to call it, in some areas.
Right.
And our flood zones are kind of interesting out here too, because it's not just, it's kind of more spotty, I guess, where you have some of those areas so you just have to pay attention. And we always say turn around, don't drown, but I feel like that's more turn around, don't drown your car.
Yes, it is. Yeah, because why flood your car out? Because the water is not moving in a tidal flood event.
Yeah, and it's brackish water too, which isn't good for your car. So it's a mix between that salt water and that fresh water, and it's just going to eat away at your car. So, we used to watch that, and one of our tower cams, it would always flood outside of my last station. And you would see people always trying to cross it, and we would always kind of be like, okay, let's see who gets stuck. And it never failed. Some people would get stuck in it. And then you would have some people that would make it through and they get stuck a little bit further down the road because it already got into their car and the engine and everything.
We have our own Lake Wavy as well outside of our entrance.
Yeah, I haven't seen that one yet.
You haven't seen it yet. There has been some mitigation done by the city, so it doesn't happen as often. I don't know exactly how the engineering works, but I believe, let's say this is the storm drain. So here's the river right here. And here's the tidal flooding. That's the source of the tidal flooding. That water comes up the storm drain. When the blockade reaches a certain pressure, when the water gets to a certain point, it shuts it down. So water can't get past that point in the pipe, and thus it can't come up through and onto the road and flood the road.
Interesting.
There's an issue with it, though. So if it dams up and we have a storm event that has a lot of rain, well, we've dammed the water from trying to going down, and then we get a flood from that. So it creates both kinds of floods. And I've seen it. It was a couple storms ago. I remember it flooded in front of the building. It flooded out to the street. So you got to watch out.
Yeah.
Lake Wavy's still out there.
Yeah.
All right. We're going to take a quick break. We're going to have Brian Michigan join us here after the break. So stand by. Welcome back to Beyond the Forecast. Brian Michigan is here. How's it going, Brian?
We're doing good. We've been a little busy today doing some exciting stuff for the future.
Okay.
Little sneak peek, I guess a little tease for you. We're doing something with the amount of salt water that we have here across Hampton Roads. A lot of fun things going on across the saltwater areas of Hampton Roads too. We've got boating, we've got the beach, we've got surfing, bodyboarding. So we've got a bunch of fun little things that everybody likes to do on the weekends. So we're going to try and bring a forecast to Wavy TV that kind of incorporates all of that stuff. So today was a fun little shoot that I did. I can't wait till everybody sees it. We did some funny little pictures with some props, and I'm not going to spoil too much of it.
Okay, don't spoil it.
It's going to be fun. It's going to be a lot of fun.
Don't spoil it. All right. We've been doing viewer questions so far, so you've missed a couple of them, but we have more, and we'll. You want to take this next one?
Yeah, so Kimberly Thomas asks, could you please explain kind of what a microburst is? So this is kind of, I feel like, pretty timely, especially with some of the storms across the mid-Atlantic. I know Pennsylvania dealt with some very heavy rain, some really strong storms yesterday. Actually, there's 2 tornado warnings north of Philadelphia while I was tracking them. So pretty strong storms. Essentially, what a microburst is a just really tall thunderstorm that grows and grows and grows, and it has all this water locked up with it. And it just releases it all at once. And you can kind of see it if you're on the distance. It kind of looks like if you see a rain shaft, it's this kind of fuzzy area coming down. That's the downdraft of the storm, but it's coming down really, really heavy. And when it pretty much makes contact with the surface, starts raining, it pushes the air out from the thunderstorm and sometimes can cause some really strong wind gusts, sometimes 70, 80 miles per hour. And some areas across the mid-Atlantic kind of experienced that the past few days with just how much water is in our atmosphere right now. There's so
that's a water-loaded source of a microburst. There's 2 ways that I can think of where you can get a microburst. Water-loaded being one, and then a dry air pocket in the mid-levels of the atmosphere being the second one. Is there a third way, you think, that you could create it?
Trying to think.
I guess because if you have dry air,
because you need the dry air for that descent to really happen really fast.
Evaporative cooling, so rain droplets are falling in the dry air. Evaporative cooling, cold air sinks, so that's sinking. I can't think of a third way.
Trying to think of a
create
third.
a microburst. There may not be.
I don't think so.
I don't think there is.
I'm thinking it would just be those 2.
Yeah, I don't think there is. So 2 different ways.
Two different ways. One of them being if it's the storm is really saturated. There's a lot of water with it, and then you also need that dry air layer to kind of help with that descent.
Yeah, you do. You totally do. That's a good question. Microbursts, I would say we can see when the environment is conducive for thunderstorms that can create them. I don't think they're not totally unexpected when they happen. They can feel that way to whoever lives in that area that's affected by them because they come very quick. I've never lived through a microburst where I've been. I have been in storms that have had some strong wind gusts and hail that did damage my house, but the wind wasn't microburst 60-mile-an-hour winds. It was probably 40.
I think out west, really across maybe the plains, is where they can really get them pretty bad. I think out there, I feel like where the storms can maybe become a little bit more robust and grow a little bit taller. Maybe say down in the southern plains or maybe through portions of Texas where you're really drawing in that deep Gulf moisture, and you have this atmosphere that's really soupy. We also call it precipitable water. PWatts, and the higher that number is, just the more water that's in our atmosphere that's able to be rained out. I think some of those areas out to the west and to the south, kind of closer to the Gulf, can usually have a tendency to, maybe experience more just because there's more water to work with. And also, depending on this, the setup that you have, again, you need that dry air kind of layer. You have these air masses, streaming in from the north and west across the plains. You can kind of get the dry air maybe at the mid levels to kind of to come in and make kind of all the ingredients align. So I think maybe out there it's a little more common, not so much on the East Coast, but certainly could still happen.
So we're gonna pull up something super advanced.
There we go, SKUTs.
SKUTs. So this is a weather balloon launch is how we get these. These happen. You can see the blue dots on the left side of the screen here. These are where the weather balloon launches happened. This is at 12Z from earlier in the day, so this is from this morning. And this is the Wallops balloon launch. And there's a lot of things we can look at, but the red line, the temperature, the green line, the dew point, and I haven't even looked at this yet for today because I don't typically look at the weather balloon launches unless we're kind of looking at a chance for severe weather. And I knew there's a chance for some water-loaded storms. I didn't realize we were this saturated all the way up.
Yeah, that's really tall. That's almost up to 300 millibars up almost.
At least,
Yeah.
right?
Yeah.
Close to 200.
Yeah, so 10 to 12 kilometers up. It's that's a saturated layer because when we say that it's humid and it's saturated because how close those two lines are the whole way up.
Yeah.
There's other things that we can look at on SKUTs too, but we're not gonna. Do we want to drive thickness right now? No, we don't want to. We don't want to do all that. Do we?
I don't think anybody wants to hear that.
No.
Yeah.
That's the part of meteorology that makes people just be like, okay, that's enough for me.
Yeah.
Yeah.
Right.
So that just shows you it's a water-loaded atmosphere.
Yeah.
If that green line right around here where the cursor is, let's say right in this zone here, let's say the green line went like this and it went down along this blue line and then it shot back over. If we had a dry slot in that zone,
That's
that
where you
would
can
be
really see downbursts potentially.
downbursts. Yep. So same kind of a thing. We're looking for a V shape right here or a kind of a C shape actually.
Our downbursts are probably more common when you do have that dry air slot.
Yes.
Way less likely if it's just a water-loaded storm.
I would say they affect more people too because those storms are typically moving. These water-loaded storms, the warnings that we had yesterday, they didn't move.
They kind of sit
Yeah.
over one
Yeah.
spot. Yeah.
So
totally.
it'll affect a smaller geographical area.
True.
Likely is what I kind of
That makes sense.
Yeah, because you
Yeah.
kind of have to rain themselves out. But yeah, that wind will really get a lot of people.
Yeah.
And they think,
Comes down.
Yeah.
It almost brings down the air with it.
Right.
And once it, the rain and then that downdraft hits the ground, it kind of spreads the air out.
Yeah.
And you kind of get those little gust fronts sometimes out ahead of storms too.
Yeah.
Yeah.
You can have some real damaging winds. I know some people sometimes misconstrue that as, oh, I had a weak tornado go through, but
Right.
nope, it's just from all that air just
Yeah,
pushing out to
pushing
the
out.
sides. Yeah.
And if we have a big storm or a big microburst where we get a huge amount of wind, let's say 80 miles an hour,
Yeah.
something
Which
extreme.
Which does happen.
Yeah, we're
Yeah.
looking at the way that the debris is laying down. So the trees are all going to lay down the same way when we have a
Straight line wind event.
straight line wind event,
Yeah.
which
Right.
this would be versus tornado, which everything would be twisted up.
Yes.
Yeah.
So good question.
Yep.
That was
Great.
good. That was from Kimberly, right?
Kimberly
Yeah.
Thomas.
Yeah, that was great. Let's do one more and then we'll take a break here. Chris McDonald, any city has lots of concrete buildings that hold in a lot of heat. Yes, that is true. It's an urban heat island effect. So will it rain harder over the city because of that heat opposed to a rural area? So we're looking at this in terms of the heat from the urban heat island changing the weather. So enhancing a thunderstorm.
It's a really good question.
It's an interesting one.
So the thing is, the effects of the heavy rain will be noticed because the cement will allow for poor drainage. So that's
Right.
going into a hydrology problem.
Yeah.
Right.
So, and I think Chris understands that. So we're not going to describe that too much. I think what we're thinking of is
Does the
heat,
actual
the urban heat island.
Yeah.
Does it affect the weather maybe downstream of an area potentially? Because you have to also remember, you have wind, you have moving air. Assuming that, there's not much, assuming a thunderstorm just grows and pops up right over top of the city. And then you have maybe another storm a little bit further away to kind of compare the two, and maybe a rural area and an urban area.
It'd be a hard way to
Very
do hard way to do a study because
Right.
you don't have a
Yeah.
control.
Exactly.
Right.
That's what I'm trying to get at. Like, how
Yeah.
do you compare a rural area to over an urban area? Because you have to have a way to measure, I guess, the two storms. They would have to be the same exact storm to be
Yep.
able to measure it anyway.
Yep.
Right.
Or else you don't have an accurate enough study.
I have a
Yeah.
hypothesis.
You
So we have a thunderstorm over a city. Let's say we're going to build a thunderstorm over downtown Chicago or a big city.
Yeah.
The temperature, or let's just use Norfolk and Portsmouth. We'll use that. So the temperature is 5 degrees warmer. The dew point should be about the same.
Right.
Yeah.
So the relative humidity should be a little lower. Thus, the air may not be as saturated compared to if the
True.
thunderstorm forms over the Great Dismal Swamp, and there's a lot of humidity there,
That's
and the
very
temperature is warmer because it's a dark space. I wonder if it would decrease the strength of the storm.
That's
I don't
That's
know.
a good hypothesis.
That
I
is
mean,
good.
that's the problem though, because how do we test this in
Right.
reality?
I don't know.
I think
I
the
don't know.
I think the overall kind of theme here is that urban areas, regardless of the storm, you're going to have a higher chance just for flooding in general.
Correct.
Regardless of the
Yeah.
storm, because that water doesn't have a proper way to drain, like in a rural area where it can, run off into streams, into creeks. You might not notice the impact as much as in an urban area. You could maybe get an inch of rain out in a field somewhere in the middle of nowhere, and not see much come from it at all. But you get, maybe half inch, a quarter of an inch in a, short amount of time in an urban setting. And that could be enough to cause some problems on the roads. Maybe
Yes.
a lot of water piling up in an area that doesn't drain well.
Yeah.
So it's kind of, I guess, depending on location.
It is.
Yeah. I don't know that you would notice it too much of a difference, though, because it's also, if you're talking about those big cities, they're really small comparatively in area. So I don't know that you
Right.
would, as storms are moving through, would you even notice really much of a difference?
Yeah, because you're exactly right. Thunderstorms can be the length of a state.
Yeah.
Or
True.
multiple states. And we're
Yeah.
talking about a city that's, 10 miles long.
Yeah, very
Right.
small.
Yeah,
Yeah.
and we're when I think of a city as what this question is asking is, I'm thinking of downtown is
Yeah.
city,
Right.
not
Right,
a
exactly.
suburb.
Yeah.
Right. Which
So-
even gets smaller because that's even like a couple miles or something.
Right.
Yeah.
Sometimes, a few blocks, really.
Right.
It's real
Yeah.
small examples.
Yeah.
Yeah, that's a good question. I think it could something that maybe we could look into in the future. I know there are studies about urban heat island effects on a lot of different things
Yeah.
on climate, and that could be one of them that I'm not aware of.
I was at in Denver for my senior year of college. I was at an AMS conference, the one in Denver, and I remember seeing some grad student, I forget what school he went to, did a project on urban heat and the heat associated with it when it came to thunderstorm development, but it was mainly for downstream areas. So like
Right.
you would get that a little bit more rising air, a little bit more heat coming from the city, and then in the upper levels, that wind's taking that heat a little bit downstream and potentially fostering growth for storms a little bit further away from the city, but in those rural areas.
Yeah.
So that's
That's a good point.
We're
Yeah.
still kind of trying to figure out the urban heat and how it's related to, I guess, other types of things other than just temperature.
Yeah.
Thunderstorms too.
But that would make more sense to me that it would affect more areas downstream
Away
of
from
it
the city, right?
Because you have to build things within storms,
Yeah.
so it takes a little bit for that warmer air
And
to
then up
get
in
up
the other,
there.
and then in the upper levels,
And
it's going
then,
to
yeah.
be carried by the upper level winds for the most part, depending
Right.
on how strong they are up there.
Yeah.
So this is a really good question.
It's a good question.
Yeah.
Makes me want to think about it more.
Okay. Well, I'm gonna keep thinking about it. I gotta keep thinking about it. We're gonna take a quick break here, and then we'll be back with more questions. There's a lot of them. There's one on astronomy that I want to touch on, and then we're also gonna get into some flooding questions as well, as that's been a timely thing with the flooding that's happened in Texas. So we'll be right back here in just a little bit. All right, welcome back to Beyond the Forecast. We have some more questions. We're running lower on time, but we still have a good amount of time to get a few more in. So I want to definitely get to some of these. You want to do a flooding one, or do you want to do a space one first?
This one caught my mind instantly. I want to do the space one.
Okay, let's do
for
the space
sure.
one. Go ahead. I'll let you read it.
So Joe Simmons asks, and this one's awesome because I think about this stuff I used to think about this stuff all the time. Could you please explain how scientists can use a telescope to see into the past? I cannot wrap my head around that concept. I was the same way kind of growing up and learning about space. Like when I heard that for the first time, yes.
Are you familiar with that?
A little bit.
So let's start with the solar system. Let's start where it's easy.
Yeah.
So we know the speed of light, the light that's generated from the sun, that takes 8 minutes to reach Earth. So when we're seeing the light bathing down on the Earth's surface, that's 8 minutes old of light that was produced. So if you were to take a solar telescope and look at the sun, you're looking at the sun 8 minutes ago. So we're looking into the past. All right, next question.
You can expand it out even farther.
Right,
how many light years away is the Andromeda Galaxy?
I don't know that off the top of my head.
You don't know that? I think it's maybe around 3 to 4 million light years away. Let's just say if that's the case, maybe Jeff, if you could maybe pull it up, we can.
I'm trying to dig it up right now.
Yeah. But essentially, what you're doing, if you say you can, see the Andromeda Galaxy really clearly in a telescope, which you usually can't because it's so far away, and you'd need, a really dark sky area to kind of see even a little bit of a shadow. But assuming that you could see it, you look up and you see it. That is light coming from the Andromeda Galaxy that is like 4 million years old.
Yeah.
So that's looking 4 million years into the past. So assuming that there was some kind of way to, for maybe a species that was on the Andromeda Galaxy to kind of look towards Earth, they would be seeing us 4 million years in the past. So very likely before humans even existed.
So if you're looking through a telescope, if you have if you're into astrophotography, that was last week's episode.
Yeah.
We're not going to talk about that right now. You're looking at an image that is that many years in the past. When you're looking at a nearby star, another object, again, just pick one. You're looking at something that is in the past. You're looking at old light, essentially, for the amount of time it took to get here. So if you were to travel 50 light years away from Earth, and let's say because I know that radio signals fade with distance, but let's say radio signals did not fade away with distance, or you had a really powerful antenna to pick that up, you would be watching the television broadcast from 1975.
That is wild.
Yeah, that is crazy.
That is it's almost scary too.
Yes.
It's so weird.
So that's how we can time travel.
Exactly.
Yeah, in a way.
Yeah.
But the problem is how are you going to get to that point?
Right.
Because if you're traveling at the speed of light, or near the speed of light rather, time slows down for you.
But it stays the same from where you come from.
Right.
It's wild. I heard this recently, and nature, when it comes to space, is so unforgiving because you see it in the movies, the time travel in the movies, and it's like, oh, you can kind of time travel one place and then bang, you're back. No, nothing passed, nothing went wrong. In reality, that's just not how it works at all.
Right. It's unbelievable. I'm not going to get too far into time dilation and things like that because I'm not an expert on that, and I'll say something wrong. I'm only saying what I've learned through some of the experts. Shout out to Neil deGrasse Tyson.
He has the best YouTube videos.
Yeah, I've learned so
you
much.
need a deep dive on YouTube. Neil deGrasse Tyson.
Yeah.
Anything space.
And the guests that he has on that he's talked to as well, they're phenomenal. But so when we're looking at a telescope to see into the past, we're looking at light that's taken a while to arrive into the telescope's bucket to capture and harness that light. So that's what we're looking at. So we're looking at things that are in the past. It's fun to look at stars in constellations like Betelgeuse. It's fun to look at other nebula because I can say when we use telescope 10, this is so many light years away from us. Or even like Mars, where it takes a good 20 minutes for the light to travel to there. So it takes time for things to get to Earth. The Voyager probe that was launched 60s into the 70s, early missions, 70s, I believe, that is now a full light day away from Earth.
One light day, not a year.
Right.
Day.
One day.
Space
all that
is
time,
big.
Yes, all that time traveling out of the solar system. Now we're that far away as we're going through interstellar space with that spacecraft.
One really fun way to kind of wrap this question up, it would take, if the sun were to disappear, we wouldn't know it for 8 minutes.
Right.
How crazy is that?
Right.
Yeah.
Space is a wild place.
Yep. Yeah, it's absolutely wild. And how much more do we need to learn about the sun? There's a lot more. That's a good question. We're going to go now to flooding. This is a question that we've gotten from two different, from Maria and from Chris. We'll read the one from Maria. Can you drown trees in floodwaters? And she wants to know how floodwaters impact trees and an ecosystem as a whole. Chris is asking, can trees drown in floodwaters, and how long before trees and grasses drown from heavy rain events? So yes, trees can drown. The tree needs oxygen in the soil. It needs air to be in the soil. It can't just be living underwater. That would be an underwater plant essentially then, like a milfoil or something else that lives in the ocean, a seaweed. So yes, they can drown. It depends on the type of tree. Some trees live in the water. So they can handle that, and they can breathe without needing to be having air in the soil. So it just depends on the tree.
Right.
And how long it can handle being submerged, essentially.
I will tell you, it also maybe depending on the water too. Like if it's storm surge, for example, and it comes in and maybe settles in an area long after the storm passes. This is what happened to at least my family during Hurricane Sandy. We had to evacuate middle of the storm because the floodwaters came up from the surge, and in our backyard there's a little depression in the soil right where the trees are in our backyard. And for 2 weeks after the storm, there was still like 2 feet of floodwater in there.
Oh, wow.
And we had evergreen trees, and they did not survive. They, one by one, as the next couple months went on, they were dropping. They were becoming brown and dying.
So this is salt water.
Salt water. So it, I guess, also could depend on maybe salt water or fresh water
Yeah, that
as
makes
well.
sense.
But it seemed like definitely did not like the salt water coming in and just hanging out. So there was a noticeable, decrease in the health of the tree as time went on after that storm and all the water had dried up.
Yeah.
That's interesting. That would make sense too, because you have some trees like in Louisiana that live in swamps, and then that's a certain type of water.
Yeah.
So if you introduce a new type of water, I can imagine that would upset the whole balance within the tree.
So I would say a lot of the trees right in the middle of the river or along the banks of the river,
Yeah.
they'll probably die not so much from being flooded, more so I would say just from the traumatic forces of being ripped apart by the rocks and the boulders and other trees flowing down the river. They were just destroyed by that, and their soil structure and everything was disturbed. So those trees are affected more so by the violent forces of the flooding. The trees that may have flooded, they probably are stressed. They'll probably maybe survive, but they also may just be stressed too, and they may not be the same.
And I'll go back.
Things like that.
All goes back to the type of tree.
Yeah, it
really
does.
depends.
It really does.
Depends on what it's able to adapt to. Because there's
Yes.
some trees like we were mentioning are along like river banks where they might have developed some adaptations to being near the water, and so it takes something different to kind of affect them.
Yep.
Yeah. I'm sure the age of the tree matters too.
Oh, of course.
So
One thing that's really good, and I believe every city in Hampton Roads and every city in Virginia, I know this is the same in multiple states, is there's a forestry department. And there's someone that you can contact when you have a question about a tree in your yard. I've done that. I have a tree in my front yard that I was concerned about and still am concerned about, because now it's starting to show more of its age. It's starting to lose more of its canopy. But a couple of years ago, it was starting to lose top of its canopy. It was okay. I had this person come by. This is not a charge for the service. This is a free service that you get
nice.
in the city.
That's awesome.
And they'll come by and they'll tell you what kind of tree it is, what the tree likes, how you can make the tree a little bit healthier, or if the tree is on its way out. So you can get this, so you don't have to feel that pressure of having getting an estimate and things like that.
Right.
If you need, because they'll say, "Oh, cut down the tree." Like,
Right.
well, no, you can learn more about the tree and the trees in your area. So the Department of Forestry, and I believe almost every large city should have one, or it'd be by county. So if you live in a smaller city, but you live in Isle of Wight or something like that, well, you can still see if there's someone from Isle of Wight that can come by, or even from the region as well. They'd be more than happy to help you out.
It's a service that I'm sure not many people know about.
No, it's a great thing. I did stories on it when I was in Minneapolis, and that's how I learned
Okay.
about it there. And then when I moved here, I said, hold on a second. They got to have something like that here, and they sure do.
nice.
And the guy was more than willing. He was super excited. They love that. So
Yeah.
it's a good way to learn, and to learn more about your trees in your neighborhood and in your yard.
Cool. I'll have to check
Fun
that out
thing.
sometime.
Next question. This is for everyone. How are we doing in time? Oh, is this going to be our last question?
Last question.
This is the last question.
Last question.
Oh, wow. This is the last question? Well, I want to do this one because this is a little bit more timely.
Okay.
This is from Julie Powell. This is, could you explain sprite lightning? What causes it? And the photos that I've seen are fascinating. Now, before we get into the description, this
I was going to say.
was not sprite lightning.
Oh, really?
No, I changed the title on it to correct it. This was labeled incorrectly when it was shared. It was called Sprite. It's actually a gigantic jet that's seen from the International Space Station. So this is a little different. These form from thunderstorms. The energy is shooting from the thunderstorm up into the sky. Let me switch out my computer here on the left so I can point to something, because I want to point out something here so we can see what's going on. Let's see. How do I do that? If I hit play, let's see. So sprites are caused by electrical activity below them, and these are not connected to thunderstorms typically. They can form from thunderstorms, and they can go high into the sky. Same thing for gigantic jets. So the description is for sprites. The gigantic jet, I haven't put a description on there, but essentially we're kind of seeing a very similar type of amount of energy moving through the upper atmosphere, but how they form or where they form specifically is a little different. Have you ever seen something like this before?
Not a gigantic
No,
jet. I
I've
don't even
never
think
heard of
actually
it.
I've seen a Sprite either.
Yeah,
I've never seen it with my eyes.
I've
never-
never seen a Sprite in person, but I've
Yeah.
seen pictures of it and it looks cool. But I've never heard of a gigantic jet
neither.
until now.
Yeah.
Are they typically, confused? Like, do people usually get them confused between the two?
I think that's what happened last
That's
time.
probably what happened with
Yeah.
the titling of the picture.
Yeah. I'm trying to find, I found something on the National Weather Service's website earlier, and now I can't find it.
Because that looks out of a sci-fi movie, that picture. The gigantic jet. It really does.
Yeah, they're both really crazy. That image, and I'll pull it back up, that is from that astronaut
That is
from the
wild.
International Space Station. Let's see if I can
I'm
find
thinking
that.
of I'm thinking of Thor's hammer.
Yeah.
You know,
There you
when
go.
it comes down to Earth,
Yeah.
that's what I'm
There
thinking
is-
of.
So the bright light from the city lights, I can't get my pointer up right now, but it's in the top right, almost to the horizon. That is Dallas. So
Okay.
we're looking at Texas. We're
Okay.
looking at areas around Texas. Austin is a little bit closer to this gigantic jet. We have Houston, that's on the far right side, that city lights right there. So you can kind of get an idea. North would be to the left.
Right,
Essentially,
okay.
so that's
Okay.
kind of your
I've got
north
it.
direction, what we're looking at there. But gigantic jets are, I don't know much about them.
That is,
But
like-
that's a great image.
Right.
Yeah, it is a really cool image. I wonder what that looked like from the ground, if you could see
Right.
anything.
I don't know
it
if you
was,
could.
because it was going straight up. So I don't
Yeah.
know if you would be able to see anything from the ground.
Yeah, and if you were flying through it and you stuck your hand out, probably not as well.
Vaporize.
Yeah, it's probably a little hot. It's probably a little hot. We have time for one more question.
Okay.
We have time for one more.
Okay.
This is a quick one. This is from Mary Brown. What's your favorite planet and why? Christy, you're up first.
So people don't consider Pluto a planet, but
Oh.
I do like Pluto.
Okay,
Just because it's the underdog.
not a
But
planet
if
anymore.
I had to pick an actual planet
Thank
now, I'll say Saturn because it's pretty. It's got the rings.
Saturn's a beautiful planet.
I
Yeah.
have two answers. One, because of my love for big storms. I'm going to go Jupiter.
Okay.
Big red dot.
Yep.
But
Yeah.
also Earth, because it's the only place I could surf. So,
Yep.
but Jupiter, no.
Yeah, because
Jupiter is
the
probably
moon. So
Jupiter. I would say for other than Earth, Jupiter.
because Titan has liquid methane.
Yes.
Lakes. So if
Wonder if
there's
you
a
could
tidal
surf on
force, you
those.
could surf that.
could surf on it.
Yeah.
Who
that'd be
knows?
cold.
Maybe
Yeah.
I'll have to go explore one of these days.
Need a stronger
Get
wetsuit.
sent out on a run. Maybe I'll do a Hang 10 episode from
From
Titan.
Titan. Let's
Hey,
go.
that'd be cool.
Let's do it.
Mine is Neptune.
Neptune.
Neptune
Okay.
does have the dark spot, which is believed
Yes.
to be a storm. Neptune is a very mysterious planet. We've only sent one spacecraft ever there. My thing is, if I ever won the lottery, I would help fund a space mission to Neptune.
Okay.
Because I would like to see. First of all, I mean, yeah, it's fun to like, okay, I want to buy a boat or I want to buy a house or buy a car. Yeah, that's fun, but it would be fun to have a project to do with the money that you win. So that's why I'd want to do that. And I want to learn more about this mysterious planet, especially some of its moons as well, because it's very mysterious. We don't only know so much. We've gotten images from Hubble. We've gotten images from James Webb. We've gotten images, of course, from Voyager, but we don't have anything else from there. I'd like to have a dedicated mission to orbit the planet and
Yeah,
to study it.
you don't hear a lot about Neptune.
No.
It's left
Yeah.
out because you have Jupiter and Saturn basically right there kind of before it, and kind of gets overlooked.
Yeah.
Yeah.
Jupiter and Saturn kind of taking the spotlight.
And I can't think of the moon's name right now because I'm being put on the spot, but one of its moons has activity that's happening maybe below the surface or on the surface.
Volcanic activity?
Yeah, like a volcanic activity or
Oh.
some type of seismic activity, because the surface from the image that we have is believed to be relatively young. So it's not filled with craters. That's a way. If there's not a lot of craters, there's something
okay.
going on the surface. So
Is it Triton?
yes.
Triton.
Yep.
Neptune's largest moon.
Yep. So yeah, Neptune. That's my planet.
Okay.
Ice.
mine.
It's saying ice volcanism.
Yes.
That's crazy. That's a
Oh.
cool concept.
That
Yep.
is. That's interesting.
Yeah, cool. Yeah, that's Neptune's largest moon.
Yeah, I almost named my dog Triton, but that was voted down. So
Aw.
yeah, Buzz instead.
That is
not
a
the name.
cool name though.
Yeah, Triton.
is cool.
Yeah.
Yeah, just screaming it across the street when the dog runs away. Triton. So anyway, thanks for joining us on Beyond the Forecast. Welcome, Kristy, to
Thank
Wavy
you.
TV10 and to the Wavy Weather team.
Yes, happy to be here.
Yep.
Excited.
We're going to be having some more fun as we go throughout the next couple of weeks. Next week, we're going to be discussing the GOES satellite. I went to the command station for that is located at Wallops Island. We're going to have more on that. We're going to be talking about hurricanes and hurricane season, an update on that later this month. So more to come on Beyond the Forecast and more to come on Hang 10 in the next couple of weeks as well.
That's right. We're ready for it.
Thanks, everybody. Have a good rest of your day. We'll see you later.